So here we have two functions, x plus 2, which is just a line, and the absolute value of x. State the domain and range of each of them. We're going to color code here. We're going to make f of x, I'm going to do in blue, and g of x in green. So, domain of my blue function, which is f of x, is everything. And my range of that blue function is everything. Domain of g of x, which is the green function, is everything. And the range of g of x is y is greater than or equal to 0. Now, for b, it says write an explicit equation. So I'm going to pull up my highlighter again. An explicit equation just has x's. It doesn't have any other functions built into it. So right now, h of x equals f of x plus g of x is not an explicit equation because it's got other functions in that. To write the explicit equation, you would go h of x is equal to, what would I write instead of f of x? X plus 2. What would I write instead of g of x? Plus the absolute value of x. That would be an explicit equation for this. Now, if we had a line and we added an absolute value, what's going to happen? Well, let's just look at this. And since these are easy graphs to actually draw, we'll draw the blue one. It has a y-intercept of 2 and a slope of 1. So there is our graph of f of x equals x plus 2. And our absolute value graph, we remember from transformations, looks like this. So if we were adding these two together and creating a new graph, and I'll draw that in red, well, this one's kind of nice because the slopes are the same. So if we start looking at some points, this one we're going to have 0 plus 2. It's going to be 2. Here we're going to have 1 plus 3, right? If we add some more points up there, 1 plus 3 is going to be 4. What's going to happen where they're the same there? That's 1 plus 1. It's going to be 2 as well. What's going to happen here? We're going to have 0 plus 2. Can you see that these always cancel out? Because one's going up, one's going down. So we get straight along there, and then goes up after that. If you want to know how does that work algebraically, okay? Because often you can tell a graph by looking at the algebra, but the absolute value sometimes throws you off. One of the things that I would look at algebraically for this one is the absolute value of x can be written as two separate functions. Can you see that the absolute value of x, some of the times on this part is the y equals x graph, and on another part of the time it's the y equals negative x graph? So the absolute value graph can be written in two parts. It's sometimes x, but that's only when x is bigger than or equal to 0. The other times it's negative x, and that's when x is less than 0. This is called a piecewise function when it's written this way, because you can describe it by graphing it in two pieces. If you want to do the algebra for your piecewise function, can you see that our final red graph, when x is bigger than 0, if this was x and you added x plus 2 plus x, can you see that you would get 2x plus 2, which would be a line with a slope of 2 and a y-intercept of 2. Does that look like this graph that we have here? Yes. And if x was negative x when it's less than 0, if you simplify this, can you see that this would just be 2 on this part, which is why we got a straight line there at y equals 2. So the algebra will show the same thing, but it's tricky because the absolute value is a piecewise function. Yeah, so the absolute value of x on this part of the graph is just y equals x. So if I did that and just had an x here, x plus 2 plus x would be 2x plus 2. And for this part of the graph, it's negative x. And if I added that second time, my x's cancel out, and I just get 2. Now, for C, write an explicit equation when you multiply them. H, or what letter are they on? P of x? P of x would equal x plus 2 times the absolute value of x. This is not, again, something that we're familiar with. If you wanted to look at the piecewise graph and say, well, when x is bigger than 0, this would be an x, right? So my equation would be x squared plus 2x. And when x is less than 0, this would be negative x. So then I would get negative x squared minus 2x. And you could graph both of those parabolas separately. What does x squared plus 2x look like? What does x squared, negative x squared minus 2x look like? And get a picture of that graph. And then from that, because it says, oh, we didn't do the domain and range for B. So let's do that domain and range first. Can you see from your red graph that your domain is still everything, but your range is bigger than or equal to 2? Now I'm going to take both of those equations and write them and remind you of what do they look like if you completed the square. So for this one here, when x is bigger than 0, can you see that if you completed the square, you'd have to add a 1 and then subtract a 1 to make it work. So the vertex of that parabola is at negative 1, negative 1. For this one, if I had y equal that, I would first factor out the negative. I would have to add 1 in here, but then I would have subtracted 1, so I would add 1 outside, and this would become x plus 1 squared plus 1. I'm going to graph both of those graphs with the dotted line. So what does x plus 1 minus 1, x plus 1 all squared minus 1 would have a vertex here at minus 1, minus 1. It's opening up, right? Over 1, up 1, over 1, up 2. Remember that from last year? Or sorry, up 3. There we go. Over 1, up 1, over 1, up 3. And this is what that whole parabola would look like. for the second one. Negative 1, 1. My vertex is here. Maybe I'll do the second one in a different color just so that helps. And it's going down. So over 1, down 1, over 1, down 3. Those are those two parabolas. What is my final graph going to look like? When is it this one? When x is bigger than 0. So the first one was the black graph. It's that graph when it's bigger than 0. It would look like this. Only that part of it. When is it the second part? When it's less than 0. So from the blue one, I have that graph. My final graph looks weird. It's got a sharp point, which is not nice because you prick your finger on it. It kind of looks like an x cubed graph, but it has that sharp point, so it's a little bit strange. Domain and range, now that we've done that, domain and range is everything. Okay, questions we can do, and we'll take a little bit of time to try these. 3, 5, and 10.